Ladies and gentlemen, boys and girls, children of all ages, yesterday we began multiplying a decimal by a decimal using the grids. In 5th grade, it's only going to be by tenths. If you multiply a decimal by a decimal, it's only going to be, and you're looking for the grid, and it's just a decimal in the tenths to the other tenths, then that's what it's going to look like. So I want to work through some problems so that you can watch it, so that you can get a better understanding of it. You aren't understand it probably perfectly at that time, but we got to talk about it. All right, this whole big square is worth what? 1. It is worth 1. This is one whole. Every column is worth what?
10.
Tenths. And so every row is worth tenths. Every little square. 100ths. 100ths. We need to know that because some of the answers yesterday didn't make them hundredths, they made them tenths. Okay, so let's look at a problem. We'll do 6/10 times 3/10. Let's see over here. 6/10 times 3/10. Now normally when you multiply, your product is bigger than your two factors, right? 7 times 8 is 56. 56 is bigger than both 7 and 8. So normally when you multiply, your product is bigger than your two factors. But that's not the case when we're multiplying by numbers less than 1. If I take the number 7 and I multiply it by by 1, what do I get? 7. So if I multiply it by more than 1, 7 gets bigger. Therefore, if I multiply it by something less than 1, it's going to get smaller. It's going to get smaller. You're going to make your factors smaller, or your product's going to be smaller than your factors. So this is less than 1, and this is less than 1. They're both less than 1. They are. So now let's look and see how we do it. In the videos you watched yesterday, and the practice you did yesterday, you had two colors when we're doing just decimals by decimals. And those two colors, you take the first factor in 6/10. And I'm going to shade in 6/10. That's 1, 2, 3, 4, 5, 6. And I'm going to shade in all of these and those. So then I have 6/10 shaded. So 6 columns are shaded. That represents 6/10. That represents 6/10. 6/10 is obviously less than 1 because this whole thing is less than 1. Then I have 3/10. The video you watched yesterday showed you a different color and shaded the different direction. I don't care if you started this horizontally or you started it vertically. It doesn't matter as long as the second one is the opposite. So then we go 3/10 this way. And okay, so 3 rows, if each one's worth a tenth, then that is 3/10, which is what we have here. Now your product, or the answer to your multiplication problem, is going to be how many hundredths are shaded in. How many little squares, so equals 1/100th, or 0.01. Okay, so now I got to figure out how many hundredths are shaded in by both colors. So these 3 rows right here are shaded by tenths, but only this part right here is shaded by both of them. So I've got 3 rows. That's confusing here. Okay, so I've got 3 rows, and I have 6 columns. So how many little squares are going to be shaded in? Mia? 18. And since we were talking about hundredths, it's 1 whole tenth, and 8 of them are left over. So if I had little, what are they called, cubes, and this was one, the flat one. You guys have all seen that. And then I had the rows, and then I had the little pieces. You'd have 0 full boxes. You'd have 1, and then you'd have 8 little pieces. You know what I'm talking about, those big square things you used to use? Okay. It's hard to use manipulatives this year because I can't pass them along. All right, this is fine if you're still thinking. I just want you to think about it, and you can grasp it as we move along. 8 tenths times 4 tenths. Is my answer going to be greater than 1? No. Because I'm multiplying less than 1 times less than 1. That means my answer is going to get smaller. If I multiplied 8 tenths times 1, it's going to stay 8 tenths. If I multiplied 4 tenths times 1, it's going to stay 4 tenths. But since I'm multiplying, they're both less than 1, my answer is going to be less than 1. Now, some of the stuff you did yesterday when we had a whole number, it was a little different. So now I shade in 8 columns. So 8 columns are shaded in. Then I shade in 4 rows. And the number that is in, or the number of little squares, that's how many hundredths I have if it's colored in both colors. So how many hundredths do I have? There's going to be 32 hundredths. All you have to do is look at how many little squares. Shade 1, the first factor one direction, the second factor a different direction. But let's look at something a little different. Now I'm going to show you the standard algorithm. This is why it works. Using the boxes, this is why it works. But now how can you work it out if you don't have the hundredth squares? Okay? This is easy. It's something you're familiar with. When you multiply a decimal times a decimal, okay, so we're going to do the first problem we had, which is 6 tenths times 3 tenths. The first thing I'm going to do is I'm going to count how many numbers are behind the decimal point in the problem. How many numbers are behind the decimal point in the problem? Total numbers is how many? Anyone?
1.
Nope, that's for this factor. 2. Because there's a 3 behind the decimal and there's a 6 behind the decimal. So my answer has to have 2 numbers behind the decimal. My number has to have 2, my answer, my product, has to have 2 numbers behind the decimal. And once I know how many numbers are behind the decimal, I don't need to use the zeros. I don't need to put the decimal points in. I can rewrite this problem as 6 times 3. Okay, so now I'm just doing regular math. And 6 times 3 is? 18. Now I go back, and I saw there are 2 numbers behind the decimal, and that's where your decimal point goes. The problem with what I see, and I've seen it often, is the kids don't rewrite the problem. All they want to do is go 6 times 3 and move the decimal point down, and it ends up as 1.8, which is not accurate. The first thing you do is count how many numbers are behind the decimal point And you got to add the 2 factors together, or 3 factors together, or 17 factors together. So 5 0 and 8 tenths times 0 and 4 tenths. How many numbers are behind the decimal point in this problem? 2. So I have 2 numbers behind the decimal point. That means my product, my final answer, needs to have 2 numbers behind the decimal point. I know that, so now I can just rewrite it. I can rewrite it 8 times 4. Why don't I have to put the zeros in?
Because when you do 0 times 0, it's going to be 0.
Good. If I put these zeros in, all I'm going to get is extra zeros all over the place, which is going to make it more confusing to me. Now, if it had a 1 up here, I would put that in, the problem. So let me finish this one, then we'll show. And 8 times 4 is 32. We come over here, we have 2 numbers behind the decimal, so it's going to be 32 hundredths. Count how many numbers behind the decimal, rewrite it, ignoring the decimals, and then put the decimal point in where the number should go. Elizabeth.
So you said that if you have a 1 in the ones place, then you would leave it there. But if you have a 1 in the ones place for the first problem and a 0 in the ones place for the second problem, do you keep the 0 or do you still erase the 0 and just leave it?
Okay, let's look at one. Let's look at 1 and 8 tenths times 3 tenths. Okay, so how many numbers behind the decimal point? 2. 2 numbers behind the decimal point. So there needs to be 2 behind the answer. Now I leave. I rewrite it. I can't emphasize this enough. Rewrite it. Rewrite it. Otherwise, I see it. 4,000 students every year, I see them just move the decimal point down, which is going to be incorrect. Is my answer going to be less than or greater than 1?
Greater than.
I'm sorry. Less than or greater than 1 and 8 tenths?
Greater than.
Am I multiplying 1 and 8 tenths by something greater than 1? No. So it's going to be less than 1. It's going to be less than 1. Now I can rewrite it. And I don't have to put that 0 in the front if it's in the ones place. If there are numbers, if there are no greater than 0 numbers in front of it, I can leave it off. If there was a 4 and an 8 and a 2, I'd have to include it. But in this case, I do not. So now I just multiply it the normal way. When we're multiplying, you're only doing 1 digit at a time. That is not difficult. So if I see you adding 1.8 up 72 times, that's going to make me insane. Just multiply. All I need to figure out is 3 times 8 and 3 times 4. That's all I need to do. 3 times 8 is? 24. So, I'm supposed to leave that decimal point off. Is 24. Which means I have to carry the 2 over. If this were not decimals, that means I had 24 ones. Which means I need to take 20 of those ones and change them in for a $20 bill. Now 3 times 1 is?
3 plus the 2 is 5.
Good. 3 plus the 2 is 5. How many numbers behind the decimal point?
2.
There are 2 numbers behind the decimal point. So did I make my 1 and 8 tenths smaller? Yes, my product is smaller than my greatest factor. Anytime I'm multiplying by a number less than 1, which includes fractions, if they're less than 1, your product's going to be smaller than one of your factors. Maybe, probably both, yes.
I don't understand how it gets smaller if you multiply the number. Because isn't multiplying supposed to make it bigger?
Only if you're multiplying by a number greater than 1. Okay, so let's think about it. Let's think about it. And remember we did a little bit of practice. And if I multiply, let's go 0 and 54 hundredths times 1. 0 and 54 hundredths times 1 equals
1 and 50. No.
0 and 54 hundredths. If I multiply something by 1, it stays the same. If I multiply 0 and 54 hundredths times 2, it's going to be 108. So it's going to be 1 and 8 hundredths. So it got bigger. Why did it get bigger? Because this factor is greater than 1. So if I'm multiplying by something greater than 1, then my value is going to get greater. The product's going to get greater. If I multiply by less than 1,
Or 1? Less than 1 or 1?
no, multiplying by 1, it stays the same. Now if I multiply this by 10, and we did some practice with that while I was on Zoom with you guys. Stupid COVID. And if we multiply by 10, then all you have to do is move the decimal point to the right once, and this is going to be 5 and 4/10. So it got greater. If I multiply by something less than 1, like 1/10 or 10 hundredths, then my decimal point moves to the left. There are some videos on my channel you can always look at. And so this is going to be smaller because I'm multiplying by less than 1. Multiply by 1, the number stays the same. Multiply by greater than 1, it gets bigger. It's twice as big. This number is twice as big as this. This number is 10 times bigger than this. Why? Because I put every decimal point 10 times bigger. So there are 10 tenths in 1. So if I have 5 tenths, I move it over to the ones place. And that number gets bigger because it's multiplied by 10. Gets smaller on the last one because it's multiplied by something less than 10. Does that make sense? Amara?
So, like you have 0 and 5400. If you were to put a 0 behind a 4, would you then say that you could do that 3 digits have to be behind?
Yeah. If I multiplied 0 and 54 hundredths times, let's go, times 100. Then there are 4 numbers behind the decimal. And then I just rewrite it. 4 times 1 is 54, because I can ignore the decimals as long as they're the leading numbers. And then I have to have 4 numbers behind the decimal point. So there's 2, 3. I got to put 1. That's here. Got to put 1 more. And that would be 54 10,000ths. Stephanie.
So like with like the third problem, wouldn't it be like you kind of like depending on like what you multiply it by, if it's like 10, 100 or whatever, you could just like if it's like 54 hundredths and you're multiplying it by 10, you just move the 5 over to the next digit. And
Yep.
the same with the 4.
Yep, because we're making 5 10 times greater than it is. So 50 tenths, or let's say it this way, if we think about it as money, 50 dimes equals 5 ones. Nobody wants to carry 50 dimes in their pocket. So I take it to the bank, I dump it on the counter, and then they give me 5 ones. That makes sense. All right, very good. Boom, shakalaka, peace out. God bless you. Do something kind. Save the bees. And hey, subscribe to YouTube, Keller GG.
No, Keller GBB.
Keller GBB, please. Keller GBB on YouTube. Thank you.